Okay, so Pura Vida. The first talk here is going to give you some insights into a group of less woody bamboos. And this work is put together by a whole group of co-authors, but it will be presented today by Dr. Lynn Clark.
Okay, thank you, Chris. Yeah, Patricia is here, but I'm going to fill in to do the talk, and she's going to answer the questions. Okay, so yeah, we're going to talk about the herbaceous bamboos here. We've been working on a lot of questions about the herbaceous bamboos for some time, especially with Brazil, because so much of the diversity of this group is in Brazil. Let me see if I can get this to, there we go. So this is the team, the main team. There's been a few other people too, but these are the main players of the people who've been doing this work. So here's just to get the stage set for the talks this afternoon. We just want to review the general outline of bamboo evolution, although we saw some of that in Jing's talk earlier. So for a long time now, we've known from plastid data that we have these three main clades, and the herbaceous bamboos, which are in the blue, are always coming out sister to the tropical woody bamboos, with the temperate woody bamboos here sister to that. And that's a very consistent signal. But as it turns out, if we look at the nuclear data, which is much more recent, the woody bamboos are monophyletic, and the herbaceous bamboos are sister to the woody bamboos. But what this tells us is that the herbaceous bamboos are a very important group to take into account if we're going to study the big picture of bamboo evolution. So for now, we're just going to focus in on the Olyreae, but you can keep that in mind as you read about bamboos, and especially the bamboo genome paper that just came out today. That will also back up that story. So the herbaceous bamboos are almost exclusively in tropical America. There's 147 species divided into 25 genera that are classified in 3 subtribes. You can see here, this is where all of that diversity is located, except for one species jumps to Africa. And then there's one monotypic genus, Brasilochloa, in New Guinea. So we have a very interesting biogeographic pattern here. And as I mentioned, a lot of the diversity and endemism in this group is found in the Atlantic forest of Brazil and the Amazon region of Brazil. So how do we know when we're looking at a herbaceous bamboo? So they basically do have somewhat woody stems. They're very weakly lignified, but they're still a little tougher than most other grasses. But they lack an external ligule, which the woody bamboos have. And they will flower pretty much seasonally. So pretty much every year, these guys are producing flowers. And the flowers show some interesting variation. You can see the forms of the inflorescences there, ranging from paniculate to kind of spicate, like there. But what's really different is that they have unisexual spikelets. The woody bamboos are all bisexual. And here in the Olyreae, it is often the case that the females and males are very strongly differentiated. Not always. There's a few where they're much more similar, but they're all at least functionally unisexual. So some of the early studies, we did sample what we had available of the herbaceous bamboos, but it wasn't very many of them. So we weren't sure. We just knew we had a clade, but we didn't really know what the internal relationships were. But as soon as we included the New Guinean genus, Brasilochloa, it became pretty clear that it was sister to the rest of the Olyreae. So there's been some more recent analyses with much more sampling, and that relationship of Brasilochloa being sister to everything else has continued to be there. Olyreae is monophyletic, and we got the signal here that Parianinae, which is this one clade here, is sister to the Olyrinae, so that's the other subtribe. This shows it a little more clearly. And also you can see that within the Olyrinae, which has the most species, there's kind of 4 main clades there. We still had a lot of questions about what was going on in some of these relationships within each subtribe, and still not completely understanding, especially the morphological, how the morphological variation was mapping to this. So finally, when we started doing, people started doing plastome analyses, that confirmed all these relationships. So you can see there's the outline right there. And that's what has continued to be the case. But I want to point out here, you can see it looks like the rate heterogeneity in Olyreae is much greater than in the woody bamboos, and that is true. But if you look, if you had a tree with all the other grasses, the Olyreae would look more like the other grasses. It's the bamboos that are, the woody bamboos that are slow. So there are a couple of taxa, though, in the Olyreae that have just, they're just insane how fast they change. So, you know, many of you were at Natal for MONOCOTSvii, and that sort of, we were just formulating a lot of these questions about how much diversity there really is, how many genera, some of those clades, like the Poaceae clade within the Olyrinae, and then Olyra itself has long been kind of complicated and problematic. And then still not really understanding all the initial evolution, especially that weird biogeographic pattern. And processes, also not really having a good handle on that. So we just started working on this. And this is kind of where we stood in 2018. There were 123 species in 22 genera in the tribe. Since then, just to give you a little of a heads up, we've already described 3 new genera within this tribe and 17 new species. The current total is right here, 25 genera and 147 species. So I'm going to walk you through the 3 subtribes. And the first one is the Brasilochloa, which until very recently, as you'll see, had only the 1 genus. We found that in addition to whatever molecular signal we could get, and the macromorphology, the micromorphology is also pretty informative. So generally speaking, the papillae, whether they're present or absent, and their distribution was giving us useful information. So for example, here in Brasilochloa, there's no papillae on the subsidiary cells. That's actually something that happens fairly frequently in the rest of this tribe. So I'm going to back up a minute to the Olyrinae, because recently one of the studies that we did was with this Poaceae clade. And so it was natural, we had material of a species called Poaceae, little Poaceae. So of course we wanted to include that. And so the person who did the study put it in there, and then, oops, it ended up being sister to Brasilochloa. So this was a big surprise for us, very interesting. And the thing is that Poaceae is endemic to Cuba. There's 2 other endemic Cuban genera, which we still haven't put into the analysis, but morphologically, these guys are a group. So we have this clade that's sister to everything else here, with one of the members in New Guinea and the rest on Cuba. So there's obviously some very interesting biogeography that we need to do. So you can see that this is to just give you the sense of what happened there. Which way did it go? We don't know, you know, did they start in New Guinea and go to Cuba, or what? Very cool. So moving on to the Parianinae, these have those spikate-looking inflorescences. And you can see the distribution here, mainly Amazonian Atlantic forest with a little bit up here in Mesoamerica. And molecular analyses have also confirmed the monophyly of this group and that there are 3 main genera. Let's see if we can get here. Yeah. And there's actually really nice synapomorphies that map to each one of these. But another oops. So they went back, my Brazilian colleagues went back to look for some more of some of these taxa, and they found this very interesting little plant and put it into the tree, and it pops out. It looks very much like a Parianella, but it pops out right here. So that sort of a cryptic genus has been growing there all this time. So this one is in press. It's going to be out fairly soon. And you can see we've got basically Pariana is out here in the Amazon, and the other 3 are here in the Atlantic forest. That gives you a closer up view of the inflorescences. This is Emulanthus, Parianella, Pariana, and Eremitas. And I don't have time to go into all the details of the morphology there, but it's very complex, very interesting. And the other type of data that we started including here is pollen. Many people, probably most of you, were taught that grass pollen is incredibly boring, that it all looks the same, and it's smooth. But the forest grasses in general, not just the Olyreae, but forest grasses in general, show actually interesting patterns of variation, and these are turning out to be another good source of data for this kind of analysis. And since we're here in Costa Rica, we need to mention Pariana parvispica, which, as far as we know, is a Costa Rican endemic, described by my major professor, Dr. Richard Pohl, quite a few years ago. And we have some very preliminary data that is putting it here. Emulanthus would be there. So we're probably looking at another cryptic genus in this subtribe, and again, one with really important biogeographic implications. This is Costa Rica, everything else is in South America. Now we come to the Olyrinae, the last of the 3 and the biggest. And what you can see here is this is fairly well supported phylogeny, but this is only part of it. Let's see, the Olyrinae, yeah, starts there, but you can see lots of support for these relationships. And so a few years ago, so this states from a few years ago, we published these in 2020. We ended up with a new genus here, looking at the Radia and Sucrea clade. And there is Brasilochloa. Inflorescences look different from the other members of this group, kind of spicate to start, and then they spread out. They've got tuberoid roots, which is very unusual in the grass family. And this is the pollen pattern that is quite different from the other, from Sucrea and also Radia. So again, multiple data sets are giving us the same signal here. And then turning to the Radiella clade and Olyra, again, more sampling and more analyses revealed another new genus. This one is still, we still have some problems because one species of Radiella pops out here. There's the rest of Olyra, and so there's the new genus. So something's going on there. We don't know if that's hybridization or what's causing that, that incongruence there. But that's Taquara. But just to show you more about this group, there's the, you can see better that phylogeny. This is Radiella. This is a Olyra here. These are the smallest bamboos. Okay, look at that's like 2 centimeters. Okay, this one is that big. And they are beautiful little plants. They're often very hard to find because they'll sort of close up and estivate during hot or dry times. And so I'm sure there's a lot more diversity there. It just has to be found and analyzed. And then Olyra, okay? For the longest time, we've been thinking, okay, there's about 24 species in Olyra, and Olyra latifolia is actually the type species that would just described by Linnaeus, so we've known about it for a long time. And you can see some of the diversity here. But when you put it into a molecular analysis, again, there's Olyra latifolias up there. I put stars on the clades here that all are still in Olyra. But the morphological diversity here, these are two separate genera. There's the female Anthecium for Lithacne, kind of this helmet-shaped thing. Here's Arborella. This one is Pyloxanthes, kind of longer, narrow. So we can't put all of these in Olyra. The only way, just like Christian was talking about with the panacoids, we have convergence, or at least some plesiomorphies here. So we are going to be naming 5 more genera for this group. And we will end up with 32 in this subtribe, or 32 in the whole Olyrae, sorry. So I want to move briefly to species delimitation because that's also challenging. It turns out there are a number of cryptic species, and we suspect there's more. Here's Pirasia leptophylla. This stuff over here was also called Pirasia leptophylla. And with more careful analysis, it's pretty clear we had 2 different species, and so this one was named as a new species recently. Another case from Radia, just briefly, we have Radia angustifolia and Portoi, and they look morphologically very similar, but when you do a genetic analysis, so there's Brasiliensis right there. This is angustifolia. Angustifolia clearly is much more closely related to Brasiliensis genetically, even though the 2 of them are morphologically very distinct. So pretty clear we've got a lot more cryptic speciation there that we need to look at. Many of these appear to be of recent origin, recent radiations, so they're not isolated reproductively, so there's probably also hybridization, there's other processes going on here, so again, we need to hit this harder. So we have answered a lot of things about these questions, but we still have some more work to do, pretty obviously. And just to wrap up here, we need to do it pretty quickly because the Olyreae are really highly threatened. They are almost all of them are forest understory plants. If you know anything about the Atlantic forest, you'll know that it is severely deforested. And that's also happening, of course, in the other places where these plants occur. And they simply cannot deal with the increased light and dryness that happens when the forest is removed. Their woody cousins, the woody bamboos, can often withstand, many of them are much better at withstanding these conditions, but not these guys. So I just want to thank everybody, and Patricia would like to thank everybody, and all of these sources of funding and our collaborators there. So thank you.
We have time. Sorry, we have time for questions. No questions.
Thank you. I was going to ask, what do we know about chromosome number and these?
I'm glad you asked that.
Herbaceous bamboos, yeah.
Yeah, it appears to be fundamentally a diploid group. Base chromosome numbers are at 7, 9, mostly. She'll add on. There is some polyploidy in the group, but it seems to be mostly pretty recent.
But the number of species that we know about chromosome number is very small yet.
Yeah.
Another person? So thank you very much.
Mm-hmm.
Thanks.
Okay.